All right, so in this lesson, I'm going to introduce to you the composition of functions. We're going to start with the definition here. Given f of x and g of x, the composition of f of x and g of x can be written as follows. F of g of x. Okay, so that is what we call a composition, and it means I'm essentially taking one function and I'm putting it into another. Okay, so in this case, my g of x is acting as the input of my f of x function. So that's one way to notate this. A second way that you may see on a diploma and other resources besides your work text is as follows. F of little circle G, okay? These two expressions here mean exactly the same thing. It means you're taking the composition of f of x and g of x, okay? So let's actually put this in application here. I have an example here. We're given two different tables of values, one for f of x and one for g of x. And using these table of values, we're going to find three different compositions here. Okay, so let's start with the composition part A. This is the composition of f of g of -4. So when you're evaluating a composition of functions, the first thing you want to take a look at is the inside function. So you're taking a look at the first set of brackets. What's inside there? Well, we need to evaluate g of -4 first. Okay, so g of -4 means when x is equal to -4, what is the corresponding y value? Okay, so to find the y value, you're going to use the given table of values. Take a look at this table here. So we're working with the g function here. We want to find out what is the y value when x is equal to -4. Well, I give it to you. That value is actually equal to -2. Okay, so once we find the value of the inside function, we can put that into the outside function. Now, what's outside is f. So we want to evaluate f of -2. And once again, you're going to use your handy tables up here to find that value. So you're looking at this table now since we're evaluating f, and you're going to look at what is the corresponding y value when your x is equal to -2. And the corresponding y value that we have here is +4. So you can conclude your answer by saying f of g of -4 is equal to +4. So there's your answer right there for the first part. Let's take a look at part B here. We're going to take the composition of g of f of 0. Okay, so first thing you want to do is evaluate what's inside the first function. So what's inside is f of 0. And you're going to use your table of values. So we're looking at the first table of values again, and we want to find what is the corresponding y value when x is equal to 0. Well, that y value is equal to 0. Okay, so once you find that value, you're going to stick it into your outside function, which is g. So g of 0, you're going to use the second table of values. At x is equal to 0, we have a corresponding y value of +5. So that's my answer. But if you want to finish this off with a nice little statement here, we can write g of f of 0 is equal to +5. So there's my final answer right there. Okay, so we have one more question here. We're going to evaluate f of g of -2. Okay, so once again, you're going to evaluate the first, the inside function. So g of -2. Using your table of values, you can see that when x is equal to -2 in the g function, we get a corresponding y value of +1. Okay, so now that +1, you're going to put it into your outside function, which is f. Okay, so f of 1, obviously go back to your table of values, and we can see at f was equal to 1, if x is equal to +1, we get a corresponding y value of -2. So that's actually my final answer there. So to conclude this, we have f of g of -2 is equal to -2 again. Okay, so there's my final answer there. So that is it for my introduction to composition of functions.